So before I start this video, I want to make a full disclaimer that if this is your very first time seeing decimal addition or subtraction, that this is probably not the right video for you. I am coming at this from the perspective that you've done this before and that this is just kind of a touch-up on this to remind us of a few rules and everything. But if this is something that you either really struggle with or you just honestly, stumbled across the YouTube verse and found this video, you might want to find something that's more of a beginning video. So when we deal with decimals, all right, so moving ahead, when we deal with decimals and we're adding and subtracting them, we're also coming at this from the standpoint of using this for pre-algebra and algebra. And that means that a lot of times they're going to have signs to them, right? So they're going to be positive and negative decimals. We deal now with a lot of positive and negative numbers, and we have to know how to combine them. So the very first thing I want to say is that the quote-unquote rules for adding decimals as far as the signs go are a lot. They're exactly the same as the rules for adding and subtracting signed integers. All right, so if you have two negative numbers and you're adding them together, you're going to get a negative answer. If you have a negative and a positive number and you're adding them together, your answer is going to be either negative or positive based upon which one has the larger absolute value. And if you have two positive numbers and you're adding them, you're always going to get a positive value. So I'm assuming that you kind of are sort of understanding that now and have a bit of a grip on that. That's an important concept to have. All right, so let's talk about this. Decimal addition. All right, so when you add decimals, the big thing that I would always, the way I look at it when you're dealing with them when they're signed is the first thing you want to do is you want to look at the signs, and if you have two signs that are the same, then you just treat it like an addition problem, okay? And when you do treat it like an addition problem, ignore the signs. So I'm not going to go negative 1.6 plus, that's silly. If you're going to add them together and you don't have a calculator, and a lot of this is assuming you don't have a calculator, okay, then what you're going to do is you're just going to go 1.6 and then you're going to add 3.8. Now, a couple things to notice here. The first thing to notice, and I'm going to rewrite this so you can actually read it. First thing to notice is that when I wrote those down, I lined up the decimals. Whenever you deal with adding and subtracting, you have to line up the decimals. When you add two decimals together, it doesn't really matter which one goes on the top and which one goes on the bottom. When you subtract, you definitely want to put the larger one on top. And I'll show you a couple examples of how that works. And then all you do is once they're lined up and your decimals are right over each other, you just bring your decimal down, okay, and put it where it goes, and then you just add, and you just do the traditional adding algorithm. So 8 plus 6 is 14. We carry our 1 over, and then you go 1 plus 3 is 4, add that extra 1, and you got 5, and you wind up with 5.4. And then because we got 5.4 and we had dropped those negative signs, and both of them are negative, we're going to put that in front of it. So our answer is negative 5.4. Okay, let's look at some more. So now we have an example where we have opposite signs. So when you have opposite signs, we treat it like a subtraction problem, and you subtract the number with the larger absolute value, you subtract the number with the smaller absolute value from the number with the larger absolute value. So what that means is if I ignore this sign right here, and I just treat these both like they're positive for a second, this one appears to be bigger. So I'm going to put that one at the top. Then I'm going to take this one and I'm going to subtract this one from it. All right, so I'm going to go minus 24.2. And then you do the same thing that we did with adding, where you bring the point down, all right, the decimal point, and then you treat it like a traditional subtraction problem. All right, traditional vertical problem. So 9 minus 2 gives me 7, 8 minus 4 gives me 4, and 3 minus 2 gives me 1. And then what we do is, because the larger number with the absolute value had a negative sign, all right, that means my answer is going to be negative. And if you are kind of going, well, why is that? Well, think about it. If you're on a number line, right, and you've got negative 38.9, and you decide that you're going to add 24.2, you're never going to quite get to 0, are you? Because you would have to add at least 38.9 to get to 0, and you didn't quite reach that. So that's a good way to kind of check yourself and make sure that your signs are correct. All right, another one. This is a little trickier and more kind of like what I think people have trouble with. Same deal. Signs are different. You put the one that has the larger absolute value, and 61, I just usually look at everything not including the decimals. 61 is bigger than 26, so we're going to put 61.1 on top, and then 26.37. Now, you're going to bring your decimal point down. This is going to be a subtraction problem. And what you always do is you make sure that you have the same number of digits after the decimal, to the right of the decimal. And so if you don't, what you do is you fill those in with zeros, right? You annex zeros, put zeros in. And then once you have zeros in, you make sure you have an even amount of digits. And then once you've got that, then you can just subtract, all right? So this would be, take, 0, right? And you go through and you can do it that way if you want. That's not how I learned, but it works. 10 minus 7 is 3. All right, you took one from there, so you got 10 minus 3 is 7, and then you took another one from there. So you have 10 minus 6 is 4, and then finally we're at a point where this number is actually larger than that, 34.73. And then what I would do is I would add these and make sure that I did it right. And if I do that, I get 61.1, because you can drop the 0. And I did do it right. Now, so I get 34.73, and because 61.1 is negative, that means my answer is going to be negative, because it's the number with the larger absolute value. And just like that number line, if you start at negative 61.1 and you go to the right, 26.37, you will never ever, you won't get to 0. You won't reach it. You will reach the point negative 34.73. All right, let's see how many else of these we have. I think we got maybe one more. All right, so same rules as integers. You've got a double negative going on here, right? You got 1.34 minus a minus 0.458. So this becomes a positive. So you will think of this as 1 and 34/100ths plus 430, or sorry, not 38. That's supposed to be 58. I wrote it down wrong. 458 thousandths. All right, and then you just stack them up and add them. So we got 1.34 plus 0.458. Let's put a 0 on here so that we have the same number of digits, and then we are adding. So 0 plus 8 is 8, 9, 7, 1, and my answer is positive because that's what I had going on over here. So I hope this is helping you. Honestly, a lot of the times when you're dealing with decimals, you'll have calculators to use. But there are a lot of testing situations where they'll want you to be able to do some sort of more simple operations with this. So you gotta have a basic grip on this and kind of know how to do it. So good luck.